P2 starts off with solving equations. It starts off with the fundamental theorem of algebra. And the fundamental theorem of algebra says that an equation with degree n has n roots. And those roots, some of them, as we talked about in Algebra 2, some of them are real, some of them are complex. And so we end up with some imaginary numbers, some real numbers sometimes when we're doing these equations. But essentially that means that when we look at, let's say in part A, that I've got the degree of that is 1, and so I'm going to have one root. In B, the degree of B is also 1, because when I combine those like terms, going through and using the distributive property, I get 3x minus 2x minus 10 equals 10. Then 3x minus 2x is 1x. We'll continue solving this one in a minute, but you can now see that I've got x to the first degree. I've got one root. And same thing happens in C, and so on. Okay, we'll talk a little bit more about that when we move on to the rest of the equation. So let's finish B. Add 10 to both sides, and we get x is equal to 20. Part A, a nice friendly equation. This is the point where you need to make sure that you understand these equations. You have to be able to solve this equation without any question at all. Subtract 4 from both sides, divide by 3, and x gives us 2. In part C, can't be afraid to work with fractions. There's a couple different ways to do this problem. The first way would be to get the fractions with common denominators. The second way would be to just get rid of the fractions. And so what ends up happening is that if I look at that fraction as just a big division problem, I can see that dividing by 5, if I were to multiply by 5, I can undo that fraction. Same thing happens with the 3. If I were to multiply by 3, I can undo that fraction. Okay, I can undo the division problem by multiplying. And so if I'm going to multiply by 5 and by 3, I'm going to just multiply everything by 15. And when I do that, I get 15 times x over 5, and the 5 is going to cancel out, and really I'm only just multiplying by the 3, because the 5's, when I multiplied by that 5, it canceled out the dividing by 5. And so I end up with 3x. Nothing cancels out with the 15 times the negative 3, so 15 times 3 gives me 45. When I look at the x divided by 3, again the 3 reduces with the 15, so with that one I'm only multiplying by the 5 because the 3 canceled out the other 3. And so now I get 5 times x, which is 5x, and then 15 times positive 1 is 15. Now I have a much simpler equation. Hopefully you realize that, that getting rid of those fractions leads us into an equation that we can solve. And so I'm going to get all the x's on the same side by subtracting 3x. Don't forget about the negative 45. Nice friendly equation. Subtract 15 from both sides. Divide by 2. And x is negative 30. Part D, some distributive property work. Go ahead and continue solving that one. On the left side we have like terms, 12 minus 3, so I have 4x. 12 minus 3 gives me 9. On the right side I have a negative 6x, and I have 8 and negative 4. 8 minus 4 is 4. Get all the x's on the same side. Usually we move the smallest one, but you could move either one of them. 4x plus 6x gives me 10x. Nice friendly equation, subtract 9. Where's my extended page? Then divide by 10. And I can reduce the 5/10. 5/10 is the same thing as 1/2. Divide both of them by 5. And I end up with x equals negative 1/2. There was a negative on there too. In E has a proportion. It has two fractions equal to each other. Again, the same idea as we had before. If you wanted to multiply by both of those denominators, you could do that. It's an easy way to remember how to get rid of fractions. And so we can do that, x minus 2 and then 2x minus 3. The x minus 2's are going to cancel out because they reduce each other, just like the 5's did in the previous problem. And so ultimately all I'm doing is I'm taking 5 times 2x minus 3. Well, what you remember that as is cross-multiplying. If I have an equal sign in between these fractions, I can cross-multiply. So I can go 5 times 2x minus 3, which is exactly what I was just going to do. Okay, so there's no issues with that. And then multiplying the other way, 13 times x minus 2. And again, if I did the same thing, multiplying by the denominators with the 13, the 2x minus 3 would cancel out, and really I'm just taking it times the x minus 2. So now a much simpler problem, distributive property. Okay, get all the x's on the same side. Usually we move the smallest one, because then we don't have to deal with negatives. And nice friendly equation. And I'm going to leave it as the improper fraction. It gives us something more to work with when we're plugging numbers back in as opposed to making it into the mixed number. We call that a linear equation, and so we ended up with only one answer here. And so the fundamental theorem of algebra held true. I need to make sure that we're looking for and keeping that in mind, that if I have an equation that's linear, has only x to the first power, that we make sure that we only have one answer for those.